Okay, here is the final topic of the term. We're going to be looking at direct and inverse proportion. Now this is similar, well this is a concept that you've done before really, but in GCSE they phrase the questions in such an abstract way that it is worth having a really solid method. And in this video I'm going to go through a contextualized version of the problem that you'll be getting, and then the abstract versions of the same problems. We're going to start by just looking at direct proportion. Okay. So, as I said in this video, concrete perspectives and then abstract perspectives. If you follow the steps in this video, follow the step-by-step guide, the method, you can't go wrong, basically. Or maybe not. Okay, so we have a car in this question, and it travels 180 miles in 4 hours. How far does it travel in 7 hours? Okay, maybe pause the video now and see what you would do if you were just given this question. So I might say that 180 miles is equal to 4 hours. So 1 hour is equal to, well, 45 miles. So in 1 hour the car travels 45 miles. And then for 7 hours I would say, well, that's 350 miles. To do that I divided by 4 in the first instance on both sides, and then times by 7 in the second instance. Okay. Now here is the same question, but in an IGCSE style. So distance is proportional to time. When the distance is 180 miles, the time is 4 hours. What will the distance be after 7 hours? Okay. Right. So the question is phrased in a slightly different way. We have this idea that distance is proportional to time. Now this particular part, the distance is proportional to time, is we can turn that into maths. And what we do is we write the following. We say distance is proportional. That little fish kind of symbol means proportional to time. You won't have seen that symbol before, it's new, but it's useful to write down in these questions. So D is proportional to time. What this really means is that, well, I don't know. I'm going to change that proportional sign. I'm going to say that D is equal to K times T. Okay. So here, I've changed that sign proportional to being equals K. This is the step-by-step guide. So this is what you would do next. Okay. So in this particular case, in this very simple case, K is the speed. But in a more abstract question, you might not know that K was the speed, for example. Okay? And recalling quickly that distance is equal to speed times time. So this kind of makes sense given our prior knowledge about distance. Next, we might say, well, we know that the distance is 180 when time is 4 hours. So we could replace those numbers, D and T, by 180 and 4. So if 180 is equal to K times 4, that means K must be 45 if you divide both sides by 4. Okay? Next. We can say that, well, if we know distance is equal to 45 times T, because we now know that K is 45, what will the distance be after 7 hours? Well, that's just going to be 45 times 7, which in this case is 315 miles. Okay? Perhaps this was overkill on this particular question, but if you can follow this method, this rigorous step-by-step process, then it makes more abstract questions far easier to approach. So here is a more abstract question. So m is directly proportional to x squared this time. M is 36 when x is 3, and the questions are A, find m when x is 5, and B, find x when m is equal to 32, sorry. Okay. Oh, sorry, 324. I don't know what I'm talking about. If you would like to pause the video now, maybe have a go. Otherwise, watch the first bit and then pause the video. So to start with, we're going to follow the method before. So we know that m is proportional to x squared, so we write that. M is proportional to x squared. That's what that statement is turned into maths. Now we can rewrite the word proportional to, well, we can rewrite the word proportional here to m is equal to k lots of x squared. That's our second step. This step is vital. You must write this step. Now we can substitute in the values we were given, so we know that 36 is equal to k times by 3 squared, because we know that m is 36 when x is 3. This means that 36 is equal to k times 9. So if we divide through by 9, we get that k is equal to 4. This will now help us to answer A, part A. Okay, so when x is equal to 5, we have, well, we know m is equal to k times by x squared, but we know k is 4, so m is really equal to 4 times by x squared. X is 5, so this is 4 times by 5 squared. 4 times by 5 squared is 4 times 25. 4 times 25 is 100. So, when x is equal to 5, m is equal to 100. So that answers part A. Part B, we're going to use the same sort of idea. So when m is equal to 324, well, we know that m is equal to k times by x squared. We know that k is 4, so it's 4 times by x squared. If we divide by 4, we get 81 is equal to x squared. So now we square root both sides. So that means that x is equal to plus 9 or minus 9. Remember that when you square root a number like this, you're going to get the plus and the minus. Okay? So this is the method to rigorously solve one of these proportion questions. You begin by using this weird fish symbol here. You'll then replace the fish symbol by equals k lots of the thing. You're going to substitute in the values that you already know to find out what k is. Then you use k to solve for the other variables. Okay, we're going to do some practice of this next week. I'll pause the video here, and in the next video we'll look at what it means to be inversely proportional and how this changes things very slightly.